Hello and welcome. My name is Alexander Bressler. I'm a study assistant at the Department of Digital Geography at the University of Vienna, and I'm here to introduce you to our latest research project concerning spatial crime perception. I will briefly tell you about what we are researching, how we gathered the data, and most importantly, I'm going to show you the results. Now, what exactly are we researching? For our most recent project, we wanted to answer two questions. What are the spatial patterns of crime perception in Vienna and Budapest? And to what extent do the spatial patterns of perceived crime correspond to the actual spatial distribution of crime in both cities? In other words, what areas are seen as safe or unsafe in those two cities, and is that perception accurate? We want to learn more about the so-called spatial crime perception gap in those cities. In very basic terms, the spatial crime perception gap means that sometimes places are considered unsafe even though they are perfectly safe and vice versa. We want to take a closer look at exactly this gap, and if you're interested in that topic, my colleague has a video on that, link in the description below. Along with our research questions, we also wanted to test three hypotheses. Hypothesis 1. Violent crime or visible crime has a greater influence on people's crime perception in space than other types of crime. We believe that people are more aware of violent and visible crimes than, let's say, property crimes. Visible crimes in that case just means any type of crime that takes place in public, robberies, drug deals, and such. So therefore, because people are more aware, they should also have a more accurate view of where those crimes take place. Hypothesis 2. Spatial diffusion effect. People mislabel areas as unsafe when they are in close proximity to unsafe areas. This one's pretty self-explanatory. Areas that are near unsafe areas are likely also considered unsafe, even if they aren't. Hypothesis 3. Spatial endowment effect. Perception of unsafety in space is heightened in areas outside one's activity space. In other words, people are more familiar with their immediate surroundings and therefore should feel safer in them. Okay, so we have established our questions and our hypotheses. Now, how did we gather the data? What we did was we opened a geo-questionnaire to the public. We made a website where people can draw safe or unsafe areas on a map, and we also asked them to draw the daily commutes so we could test hypothesis number 3. All of this is of course a bit more complicated than that, and if you would like to learn more, we also have a video on this topic, again linked below. We also approached Hungarian and Austrian authorities for crime data, which they kindly shared with us. We ended up with a lot of sketch maps. The sketch maps were unified into a grid of hexagons, and then we combined that with the crime data and filtered out the statistically insignificant results. And this is what we ended up with. What you see here is the crime perception gap for Vienna and Budapest. This is what the answer to our research question looks like. We can see the spatial patterns in crime perception. Dark and light green indicate an area is perceived as safe, red and orange indicate that they are seen as unsafe. The gray parts are statistically insignificant. And what we can see is some interesting differences between Budapest and Vienna. For Budapest, we can see a very clear east-west divide, with the west being seen as safe and the east as less safe, with the Danube dividing the city. That's not the case in Vienna. There's no such clear division there. Now, when it comes to accuracy, the story gets even more interesting. Light green indicates the inaccurate safe perception and orange inaccurate unsafe. In Budapest, a lot of the areas that are seen as safe are accurately seen as such. At the same time, survey respondents severely overestimated the danger of a very large area, as this big chunk of orange indicates. It's the opposite for Vienna, where crime perception is a lot more accurate. We see a far smaller number of orange cells, but at the same time, Viennese participants overestimated their safety more than participants from Budapest did. All of that is of course not to say that something bad will happen to you in the red or light green areas. This is all relative. Now let's return to our hypothesis again. Hypothesis 1, we remember people are more aware of visible or violent crimes and have a more accurate perception of them. As we can see on the table, when you look at the kappa statistics, it is essentially true. In both cities, our participants are more likely to accurately identify violent crime hotspots compared to other crime types. That being said, it's not true for visible crime, and the overall accuracy of crime perception is rather low in general. Hypothesis 2, spatial diffusion. We suggested that vicinity to crime hotspots has an influence on accuracy. And as we can see on this map of the inaccurate unsafe areas, this effect is very prominent in Budapest. Here the crime hotspots form a sort of boundary, and everything between those spots is also seen as unsafe. The same thing is also happening in Vienna, but less extremely so. Here only the direct vicinity of the hotspots are also seen as unsafe. And finally, hypothesis 3, spatial endowment. Based on the commutes and daily routes people have shared with us, we could see where individual participants felt more or less safe. And, as can be seen on this graph of the cumulative frequency distribution, that seems to be the case. Areas that our participants frequently visit are also more likely to be considered safe by them. This already concludes a brief overview of our latest project. Sadly, that's all the time I have to tell you about it, but if you want to know more, we have a paper coming out shortly. It will be linked in the description below once it's out. Thank you for watching.